Hi, it's Miss Elizabeth. Welcome back to Rock Island Public Library Summer Math Club. You know, our theme is reading colors your world, and I sure hope that you are reading lots of books this summer. One of the things that people forget at the library is that you can also check out math books. I know that seems like a funny thing, but I really actually love math books. So if you look at the Dewey Decimal System, you go to the 510s, you're going to find a lot of math books. So this book is found on J516.154, and it is cool string art. So there's a whole series. This one is cool flexagon art, and this one is cool tessellations. And so for me, I think this is fun because often we just think of math as being about arithmetic, right? Adding 1 plus 1 is 2, or doing fractions, or learning our times tables like skip counting, where we can count by 2s, 2, 4, 6, 8, 10, and keep going. We could count by 5s, but those are all great things to do, but I like to investigate some other aspects of math because a lot of math is looking for patterns, and mathematicians are often asking questions that they don't know the answers to. So one of the questions that mathematicians ask themselves is, what is the fewest number of colors you need to color in a map that is on a two-dimensional surface? Now, there's an important thing to mention about the dimensions, and we could talk about a little bit of that, but for right now, a two-dimensional surface means it's flat. So you should have this in your packet, Map Coloring Basics. So I took this, and instead I kind of drew my own copies of it because I want to use this as my template. Now, if your parents don't mind printing off a lot of these, they can make a copy of it, but if they don't like to make a copy, you can just take paper yourself and draw your own pictures, okay? Which is what Miss Elizabeth did. So the first question we're going to ask ourselves is, I have this little, like what I call a checkerboard shape, and I want to ask you, think about, can you imagine, have you ever seen a checkerboard before? How many colors do you need to color in a checkerboard? The fewest numbers of color. Because, I mean, yes, I could put as many colors as there are blocks, which would be, let's do a little bit of the arithmetic. 1, 2, 3 on top, 1, 2, 3 going down, 3 times 3 is 9. We could skip count by saying 3, 6, and then 9, or if you need to, you could count 1, 2, 3, 4, 5, 6, 7, 8, 9. So you know there are 9 squares. We could use 9 colors, but we want to see the fewest number. So the fewest number is 2, because if you've ever seen a checkerboard, a lot of times they are red and black, or maybe black and white, or maybe you have some other colors. So I'm going to choose, if you saw last week, I kept using a lot of purple and yellow. So I'm going to use purple and yellow for this. All right, so then I'm going to switch to purple. And then purple underneath here. And it's okay if they kind of touch, at the corners they touch. That doesn't matter. We're saying we don't want them to touch on the sides, on the edges. So that's some math language right there. The corners are called vertices, and the edges are the sides. All right, so look, we have a checkerboard, and so we've shown that we can use 2 colors, and that's the fewest number of colors to color in that particular pattern. Now, you might see next to it is this one. And it's a checkerboard, except this part here has been modified, meaning we've taken out this line. So now we've changed this slightly, and we have to ask ourselves, do you think only 2 colors will work? Well, before I actually color it in, what I did was if you have buttons or beads or something at your house, I just found buttons because I have buttons in a lot of different colors, and I thought, well, I can use these buttons before I decide to color. So I'm going to put a pinkish color here, and then I'm going to say, well, these 2 can't be pink, so I could put this kind of like this representing my pinkish color, and I could put that there, and then I'm sort of like, what's happening here? I don't think I can just put two colors, because then if I put this color here and this color here, I can see that, well, I could put that there. What's happening here? I mean, if this color is really the same as this one, I know it's not really, but I'm saying it's close, that we can't put this color here. So we're going to have to come in and put in a third color. And now we have to say, can we just go ahead and put a greenish color there? And yes, we can. So we know now that we're going to need three colors. So I use these beads, or these are buttons, or you could use whatever you have to sort of map it out so that you don't have, or you could just keep drawing a lot of pictures and figure it out. That's up to you. So those are just some options of ways to kind of map it out and think about what's happening. So I'm going to choose another color. So I'm going to come in and I'm going to make this one this color. And then I'm going to put my purple in the corner like this. And then I know I can go down my diagonal just like I did over there. And then I could put my yellow in. And if you wanted to, you could put the blue there. It doesn't matter, it's up to you. But we can see that we need to have a third color, because otherwise we would have two colors that were the same color touching each other. So this is what mathematicians look into, like how can we figure out what are the fewest number of colors we can color a certain pattern. So you have this coloring sheet, and your job now is to think, do you think this shape with this pattern, will it take two colors or will it take three colors? So I want you, maybe using buttons or something, to plot it out and you tell me what you think. So the question I asked was, how many colors do we think we can use for this one? So I think it's a good idea if we start with the center, and then I realize I can, oh yeah, this can go yellow, this can go yellow. Remember, we're looking for the fewest number of colors that we can use. So I see that, oh, this worked out with just using two. So if you guessed two, you guessed right. Good for you. Because remember, the fewest, 3 is not the fewest. Yes, of course you can color it with 3, but we want to find the fewest number, so that would be 2. Now, I already drew this other shape, and something about the way that we've added these extra parts will change the number of colors. Because as we saw that happen in this particular one up here, we can see that probably we can get away with coloring this shape with 3 colors. So I want you to think about, you could use your buttons like we did before, and we can map out how would we do this in 3 colors. So you can take your buttons, or you can take a little marking, and without coloring it in, see if you can figure out a way to color this shape with only 3 colors. Pink and pink here. And then if I put the red in those, then I could put white in the outer. So this was just sort of me trying to figure out how I could color it using some other, without actually coloring it. And now that I see, oh yeah, I can do it that way, I'm going to pick my crayons and I'm going to do it. So I'm going to choose, I'm not going to use exactly the colors I picked with my crayons, the same here, but now I understand what I'm going to do. So I'm going to color in the center. And then I decided to color the triangles here all the same color, because they're not touching each other except on a corner, on a vertex. and then I decided that I could change this, and I could do it, if I want to do this, I could make this purple. And there's more than one way to do it. You don't have to follow my pattern. You can find your own pattern and see if you can color this in just 3 colors, and make sure that you don't have any 2 colors touching each other. So this is the pattern I decided. This is the colors I chose. And so you can draw this shape and see if you can figure out how to color it with just 3 colors, and maybe find a different pattern of colors, but only use the fewest, which would be 3. There's no way to do it with 2. Okay? So that's what we're doing.